The weight of hot or cold rolled coils is dependent upon plate thickness and length. In general, coils will weigh between 5 and 15 tons, with diameters between 1.2 and 1.7 meters. The most common weight is around 10 metric tons, but on rare occasions, coils can weigh up to 25 or 30 tons. Each coil is tightly strapped through the center and around the circumference using metal banding. The width is usually between 1 inch, 25 millimeters, to 1 1/4 inches, 31.75 millimeters in width. Coils of cold rolled steel are strapped as with hot rolled coils. They are then covered in bituminous paper, and on top of this, waste steel sheeting. Edge protectors are fitted to inner and outer circumference at both ends, and the whole secured by 4 equidistantly distributed axial and up to 3 circumferential metal straps. This high-density cargo should only be loaded on tank tops and never in 'tween decks. Tank top strength must never be exceeded, or the vessel structure will be damaged. Therefore, the deck load density limits must be carefully considered during cargo planning. The maximum permissible tonnage to load is calculated using the formula: tank top area, meters squared, times tank top strength limitation in tons per square meter. This can also be found in the cargo stowage manual. The strongest points of any tank top are those directly above transverse and longitudinal frames. Load plans should aim to place coils as close as possible to these strong points. This must not lead to spaces between coils or rows, however. A tight stow is more important than placing coils precisely over the strong points. Dunnage must also be used to prevent damage to the tank top. All dunnage should be of dry wood, whose water content is no greater than 15%. This will reduce compression of the dunnage and lessen rust damage to the coils. Dunnage laid on the tank top should be 4 inches, 102 millimeters wide by 1 inch, 25 millimeters thick. This dunnage will also protect the cargo from ship sweat. 2 rows of dunnage should be laid athwartships for each row of coils to be placed on the tank top. Each row should be laid so that it will be near the ends of the coils placed on top of it. Where coils are particularly heavy, 3 rows of dunnage may be used. It is very difficult to load coils directly into areas of the hold outside the hatch square. Therefore, each coil is loaded onto a steel plate placed in the center of the hold to protect the tank top. A forklift truck with a single cylindrical tine then transports the coils to their final position. Each coil is placed on the dunnage with its hole in the fore and aft direction. The first coils are loaded in the port and starboard wings of the tank. Each successive coil thereafter is added towards the center of the hold. To prevent movement of the coil as the vessel rolls during transit, chocks are added after each coil is put in place. Due to their shape, even chocked coils are likely to move transversely when the ship rolls. One way to prevent this dangerous transverse movement is to use a locking coil. This coil should be loaded on the 2 innermost of the bottom coils, forming the first of the second row. Every effort should be made to reduce the distance between these coils to as small as possible, which may include the introduction of dunnage to reduce the gap. In order to be effective, it should be placed so that the gap between the 2 innermost coils is no wider than 60% of the diameter of the locking coil. The weight of this coil increases the forces on the 2 adjacent coils, locking them and their neighbors in place. The next row of coils are started in the wings of the tank, above and outboard of the bottom row. The second row is then completed in the same way as the first. Again, the center locking coils and wing coils are the first coils loaded in the third row. A 3-layer pyramidal type loading pattern is shown here. There are a number of variations of loading pattern dependent on the size and weight of coils. The total number of tiers is dependent upon the size of coils and strength of the tank top. However, it is usually never more than 4 or 5. Where there is a gap between the outermost coil and the ship's side or hopper tank, additional dunnage must be inserted. This void-filling dunnage must be of substantial construction, capable of dealing with the likely loads exerted on it. Typically, 4-inch by 4-inch timber is used in these constructions. Similar dunnage must be inserted where a cargo hold is not square or rectangular, for instance, at the forward or after end of cargo spaces. The accelerations generated when slamming heavily in a seaway can cause compression damage to coils. Compression damage is also caused when the overstow is too high or heavy. Each coil is stowed in the cant line of the 2 coils beneath, and these bear 50% of that coil's weight. Each additional row therefore adds stress cumulatively to the bottom layer. The best method of lashing of steel coils is to use metal bands. These bands should be threaded through the core of each coil and each of the 2 coils directly beneath. Each band is applied separately and tightened to an appropriate uniform tension throughout the stow. A mechanical hand-operated tool is used for tensioning the metal bands. At least 2 crimp seals should be used when joining metal bands. If a wire rope is used, turnbuckles must be opened to their maximum extent before the rope is threaded through. After initial tensioning, not more than 1/3 of the thread should be inside the turnbuckle. This will allow additional tightening before sailing and during the voyage.